Okay, again, good morning, good evening, good afternoon, whatever time it is. Today we're going to look at another question which was posed today, and it's in the topic of factorising, but it's looking at using both the factor theorem and the remainder theorem, and also thinking about how we can fully factorise a cubic. So I'm going to go through the full process of fully factorisation of a cubic equation. So, like always, if you haven't done this question in class, I would encourage you to have a go at this question beforehand. So just pause the video now. However, if you were in class, you'll know that there was a few strategies which I employed. So the first thing that this question is telling us is that we've got this function of x. Let me just make this full screen for us. We've got this function of x, which is x cubed plus 2x squared minus 11x minus 12. I'm going to use crayon. Lovely. And it says evaluate f of 1, f of 2, f of negative 1 and f of negative 2. Now there's 2 marks on offer in here, and all we're doing is substitution. So we're replacing this x here with a 1. So therefore for f of 1, all I'm looking at is 1 cubed plus 2 lots of 1 squared minus 11 lots of 1 minus 12, which is going to give us 1 plus 2, which is going to give us minus 20. F of 2, when we work that out, is 2 cubed plus 2 lots of 2 squared minus 11 lots of 2 minus 12, 8, 16, which is going to give us minus 18. Looking at f of negative 1, we're doing the same thing. We're going to substitute a negative 1 cubed plus 2 lots of negative 1 squared. Be careful with that because that's going to take you to positive 1. Minus 11 lots of negative 1 minus 12. So it's minus 1 plus 2, which is going to give us 0. So we know that something special happens here. And f of negative 2, again, we substitute in negative 2 cubed plus 2 lots of negative 2 squared minus 11 lots of negative 2 minus 12. And that's going to give us minus 8 plus 2, 8 plus 22, 10. So now we've done that, we can evaluate them. So these 3 aren't roots, whereas we know that f of negative 1 is going to be a root. So therefore, we know that if we want to factorise this and factorise it fully, because negative 1 is a root, that means we can take out a factor of x plus 1, because that will be the bracket, which when we substitute in negative 1 will reduce to 0. So, thinking about how we do this, I'm just going to draw out my grid for a factorisation of a cubic, and I don't think I've given myself enough room there, but we'll go with it. So I know that I've got an x and a plus 1. I know that my constant term is minus 12, and I know that my cubic term is cubed. That's all the information I need to then go about fully factorising. So x and x cubed means I have to have an x squared here, which is going to give me an x squared here. Altogether, I need 2 lots of x squared. I have 1 here, so that means I must have another 1 here. So this is plus x. So this is going to be plus x. I have a plus x, and I need negative 11 in total, so I need 12 less x's. So therefore, this has to be negative 12, which we can check is correct. So from this, I've got my bracket to be x plus 1 and also x squared plus x minus 12. Now we're all competent mathematicians here, but x squared plus x minus 12 is going to have factors of 4 and 3. As this is positive, it's going to be x plus 4, x subtract 3, and of course we have this x plus 1 remaining. thank you. That's the end of the lesson.